Bonjour à tous. Hello, everyone. My presentation is very different from the last one. It's about an environmental study on cumulative effects in West Central Alberta, and more specifically in the Fox Creek area. This project is conducted in close collaboration with professors and students from INRS, and as you can see on the slide, with also other universities and organizations, and especially NRCan. Voici par exemple la liste des personnes qui collaborent au projet. J'ai mis en bleu les chercheurs de Ressources naturelles Canada qui sont soit à la CGC, au Service canadien des forêts, à Canet Énergie ou au Centre canadien de télédétection, et en vert les chercheurs et étudiants de l'INRS. Il y a plus d'une vingtaine de personnes qui sont impliquées, dont 5 étudiants à la maîtrise ou au doctorat. The study area is located just southwest of the town of Fox Creek in west central Alberta. It extends over 700 square kilometers. This industrial area is mainly forested and unpopulated, so there are no residential or farm wells. The only water supply wells belong to oil and gas operators. Fox Creek was selected because it has been one of the most active regions for oil and gas production in Canada over the last 50 years. Only in this limited study area, there are over 800 oil and gas wells. The regional bedrock aquifer is located in the Pascapou Formation, located here in yellow. For those of you who may not be familiar with the term aquifer, an aquifer is simply a geological formation in which groundwater can be pumped. So this Pascapou Formation is the most important groundwater supply in the province. It is a non-marine unit that corresponds to a complex succession of interbedded mudstone and siltstone with sandstone channels, and that is known to contain some coal seams. Le projet Fox Creek avait deux objectifs au départ, caractériser l'aquifère régional peu profond, situé dans la formation de Pascapou, et étudier l'intégrité de la zone intermédiaire qui est située sous les aquifères superficiels et au-dessus des formations qui ont été ou qui avaient été ciblées par l'industrie gazière et pétrolière. C'est cette zone qui contrôle la vulnérabilité des aquifères superficiels à une contamination potentielle qui pourrait provenir des activités réalisées en profondeur. Donc, elle est très importante, mais très peu caractérisée. Le troisième objectif est arrivé rapidement, quelques mois après le début du projet, parce que le gouvernement avait décidé d'ajouter l'évaluation des effets cumulatifs à ces thèmes prioritaires, et aussi, évidemment, parce que la région s'y prêtait bien, puisque Fox Creek est une région fortement industrielle depuis plusieurs décennies, et surtout pour le pétrole et le gaz et le bois, l'industrie forestière. The Fox Creek project includes the following components or studies: hydrogeological modeling and coupled surface water groundwater modeling, which integrate the knowledge gained from existing data and fieldwork to study the system hydrodynamics. The estimation of water budgets in both disturbed and undisturbed areas to better understand the hydrological cycle over the course of a year, and make comparison of the different components in areas where there are still trees and natural vegetation and where everything was cut down. There is also geomechanical modeling to study the potential impacts of hydraulic fracturing on the integrity of the intermediate zone. A study of the evolution of landscape over time using satellite imagery and air photos. A geochemical study to determine if water resources have been affected by industrial activities over the past 50 years. A study of vegetation recovery in disturbed forest ecosystems. A study by Canet Energy that uses a combination of lab testing and numerical modeling to investigate the fate of chemicals in the event of a surface spill, flowback, or produced water. And finally, a general study aiming to identify the challenges and barriers that people face when assessing cumulative effects, and then to make recommendations for improving the current assessment process. I would also like to mention that the snow data that are being collected within the framework of this project will be used in a Canada-wide study assessing caribou's ability to access lichen by the CCRS. The project involves fieldwork. 9 monitoring wells were drilled using a conventional technique and logged 2 years ago. Their depths range from 35 to 90 meters. One of them was drilled on an active oil and gas well pad. 3 additional boreholes were drilled last fall with depths from 30 to 100 meters to obtain information on the vertical hydraulic gradient and the water chemistry, but also to obtain cores for density, porosity, permeability, and S&P wave velocity analyses, as well as for rock geochemistry. But all 3 had to be converted to 30-meter wells because the walls of the deepest well collapsed. Despite this unfortunate event, the cores we obtain from the deeper borehole are very valuable as they illustrate very well the great heterogeneity of the Pascapoo Formation and its highly variable degree of consolidation. Some sandstone intervals at various depths and between well-consolidated intervals showed little or no consolidation. I'll come back to this and to its implications later. Groundwater from these monitoring wells and from 13 shallow wells belonging to oil and gas operators was sampled. Hydraulic tests were performed in the monitoring wells and in superficial sediments, and a gauging station was installed because there was none in the study area. However, a variety of issues occurred. As part of the master's thesis on the estimation of water budgets, monthly visits to 5 paired sites have been conducted over the past 12 to 18 months. The work includes collecting data or samples from lysimeters, soil moisture sensors, rain gauges, and rain collectors on frost-free days, and from the snowpack to obtain density, thickness, and chemistry during the winter. Je vais maintenant présenter quelques résultats, très brièvement. As mentioned earlier, the Pascapoo Formation hydrogeological properties are very variable and even over the different sandstone intervals, as the hydraulic conductivity or permeability and porosity are locally controlled by diagenetic alteration of calcite or clay cement. Highly altered sandstone intervals are very friable to even unconsolidated, as you can see on the picture, and resulting in high hydraulic conductivity and yield. The 2 current hypotheses for the unconsolidated nature of some of the sandstone beds are the almost total absence of cement in the initial pore space, or the dissolution of the initial calcite cement. The second hypothesis seems more plausible, but analyses are currently underway to verify it. As there was no hydrogeological data available for the study area on superficial sediments, in situ hydraulic tests and grain size analyses were performed on samples from the drilling of monitoring wells and the master's project on water budgets. Results confirm that the superficial sediments contain a lot of fine particles, in general more than 70%. Therefore, estimated hydraulic conductivity values are low, in the order of 10 to the minus 8 to 10 to the minus 7 meters per second, confirming the values previously obtained in situ with Guelph permeameters. Vertical recharge, which is a key parameter for water management, has been estimated using a few methods. As I mentioned earlier, a gauging station was installed in September 2020, but many problems occurred. So values for recharge mainly come from a provincial report, from a rough water budget, because most weather stations in this region have many data gaps and short time series, and from hydrogeological modeling. We also used a provincial gauging station draining a much larger watershed to obtain an estimate, as you can see on the slide. And in fact, they all provide relatively low values, ranging between nearly 0 and 80 millimeters per year, in agreement with the large fraction of fine particles in superficial sediments. Borehole geophysical logging, among other things, helped identify the presence of a few beds with high velocity and density, mainly found in sandstone, that were interpreted as cemented. Thus, they may represent barriers to vertical flow. And the poorly consolidated samples, the poorly consolidated rock, of the Pascapoo Formation caused wall roughness, as you can see on the picture, and thus affecting property estimates. To help with the interpretation, core samples were sent to a lab for various analyses, which I mentioned earlier. Groundwater from most wells is of the sodium bicarbonate type, shown in pink, but a few wells located upstream or that are shallower have a younger calcium bicarbonate type, shown in green. Surface water samples are all of the calcium bicarbonate type. As these samples were collected during the summer, this suggests that the streams are mainly supplied by local groundwater during this low flow period. Thus, we believe that there would be two distinct systems in the freshwater Pascapoo aquifer, a local, shallow, unconfined system, probably from 0 to 30 or 50 meters deep, that is connected to the hydrographic network, and a deeper confined system, deeper confined system that is disconnected from the streams. And that is also supported by water level data. Based on the fact that high yields are available, vertical recharge is low, some sandstone intervals are barely consolidated, that we found large uncorrected radiocarbon age values generally greater than 10,000 years, which is quite unexpected for this relatively small watershed. This likely indicates that a significant contribution of water comes from the Rocky Mountains. Only 7 wells were found to contain small concentrations of dissolved methane, all of microbial origin. This methane is probably associated to the presence of coal that was often observed during drilling. La modélisation numérique, à la fois à l'aide de modèles hydrogéologiques 2D et 3D et le modèle géomécanique, a permis de montrer que les remontées de fluides profonds suite à de la fracturation hydraulique sont très peu probables, on pourrait même dire improbables, ce qui représente une très, très bonne nouvelle. The Shaw model that simulates heat and water movement and that takes into account soil freezing and thawing is being used to simulate the different components of the water budget in the disturbed and undisturbed areas for an upland site and a lowland site. At this time, only the growing season was simulated, but this period shows that evapotranspiration at the upland site generally equals or exceeds precipitation. The moisture in the shallow soil layers is thought to come largely from snowmelt and a few rare large rain events. This water cannot infiltrate below a few meters due to the low permeability of the superficial sediment cover, and it allows vegetation to grow and it feeds the wetlands. As a comparison, the water table in the bedrock aquifer is much lower, typically below 10 meters. For the lowland site, the results show that the disturbed area has an evapotranspiration value nearly half that of the undisturbed area, keeping the soil very moist, likely preventing the vegetation from recovering to its natural state.
Il vous reste 1 minute, merci.
OK, merci, je vais vite. L'étude sur l'évolution du paysage a montré clairement qu'aujourd'hui, les feuillus occupent une superficie beaucoup plus grande qu'en 1949, entre autres à cause des activités humaines et des changements climatiques. On voit aussi que les milieux humides ont diminué et que les coupes d'arbres ont évidemment augmenté pour toutes les activités qui ont rapport aux 2 industries que j'ai nommées tantôt. Et ça, ces grandes coupes linéaires-là ont évidemment un impact sur les caribous ils sont très vulnérables aux prédateurs. Ça affecte aussi leur façon de se nourrir. Finally, results of the general study on obstacles and challenges encountered in the cumulative effects assessment process that is based on interviews and discussions with consultants, federal employees, and First Nations groups show that although cumulative effect assessments have been a requirement of environmental assessments in Canada since 1992, so for 25 years, several barriers remain, such as lack of data or problems accessing existing data, such as industrial data. The recommendations include First, legislation to make data publicly available, of course. Second, the legal requirement to monitor certain data to be determined maybe according to a given type of industrial activity that could or should be used to reevaluate operating permits maybe every 5 years. Three, consolidation of all requests to Indigenous communities within the federal government in one place to avoid duplication of work and fatigue related to multiple consultations. And four, developing long-term government plans, thus ambitious plans, to conduct regional assessments in different regions of the country, particularly those with high industrial activity, past, current, and future. Thank you very much.